Okay, well, welcome everyone to the Institute of Fiscal Studies annual lecture. This year we're thrilled to have with us Raj Chetty, and he's going to be talking on a subject of great interest, improving equality of opportunity, new evidence and policy lessons. I'm guessing from the number of people in the room that a lot of people know who Raj actually is, but I'll tell you just the same for the record. He's the Bloomberg Professor of Economics at Harvard. He's won an incredible range of awards for one so young, and it would be tedious to read them all out, but some of the most prestigious include the John Bates Clark Medal, which he won last year, and also gosh, I wish John D. Catherine T. MacArthur Foundation Genius Grant the year before. I mean, this is terribly bad for you. It's bound to go to your head. But he's been amazing. He's been amazingly productive and has produced some serious economics along the way in an area which is very well aligned with IFS interests, taxation, social insurance, education, things that we really do a lot of work on ourselves. So, you know, he's an absolutely ideal annual lecturer, and with that very brief and completely inadequate introduction, I will make way for the main event. Raj.
Thanks very much. It's really a pleasure to be here in London, and I've had a fantastic time today talking to IFS researchers and policymakers. It's a very exciting place to be. So I'd like to start today by talking about how opportunities for economic mobility compare across countries around the world. Now, there are many ways in which you might think about measuring social mobility. I want to think about one statistic to be concrete, which captures sort of the notion of what we call in the US the American dream, or the idea of going from rags to riches in some sense. So let's think about the statistic of the odds that a child born to parents in the bottom fifth of the income distribution reaches the top fifth of the income distribution. So what fraction of children make this leap from the bottom to the top? So various studies have been conducted on this question and have measured a number that looks like this. And in the US, I've done work with my colleagues using income tax data, where we find that that probability is 7.5%. In the UK, there's been some very interesting work done using the cohort studies data, where roughly we think you get estimates around 9%. I should note that in the UK, and this is a theme that I'll come back to, the data are currently much more limited than in the other countries. So to give you an example, in the US, that 7.5% statistic is based on 10 million observations. In the UK, the 9% statistic is based on about 2,000 observations. And so that's something where I think that it's imperative for the UK to have the types of data sets that the US and Scandinavian countries have that are very useful to study these questions. So if you look at Denmark and you look at Canada, you find much higher probabilities. So sometimes people react to this evidence and say, you know, even if you look at Denmark or Canada, the probability of success doesn't seem all that high, right? Only 12% or 13%. Well, you have to remember that unfortunately, no matter what you do, you can't have more than 20% of people in the top 20%, right? So relative to that maximum, these are actually quite large differences. One way I think about it, the way I talk about it in the US, is that your chances of achieving the American dream in some sense are nearly twice as high if you're in Canada than if you're in the US. Now, those differences across countries appear striking, and they've been the subject of a lot of policy discussion. But it turns out, and this is what I'm going to focus on in this lecture, social mobility actually varies even more across areas within the United States. So what we've done in this project that I'm going to discuss is calculate the types of upward mobility statistics that I was just showing you for every metro and rural area in the United States using de-identified tax records covering 40 million children and their parents, which is really the type of data you need to calculate the very granular statistics that I'm going to show you. So to illustrate, let me start by comparing social mobility in two cities in the US that we typically think of as having pretty vibrant economies with substantial job growth and so forth. So this is Salt Lake City, Utah versus Charlotte, North Carolina. So let me start by looking at the data for Salt Lake City. So what this does is takes all children who grew up in the Salt Lake City metro area, and it plots the percentile rank of the child in the national income distribution versus their parents' percentile rank. Okay, so the first way you might think about looking at these data is just to do a raw scatter plot, right, of one variable versus the other. Now, if you do that with 10 million observations, you're going to see a giant blur and won't really be able to discern any patterns. So the way this graph is constructed is we bin the x-axis, the parents' percentile income rank, into 50 equal-sized bins, and we're plotting the mean of the child's percentile rank within each of those bins. So technically, this just gives you a non-parametric representation of the conditional expectation function. What does the average child's percentile rank look like as a function of their parents' rank? So you can see that this relationship is strongly upward sloping. It's consistent with prior work. If you're born to richer parents, you yourself are richer. Now, one thing I want to stress is that we're ranking both the parents and the children in the national distribution. So we're not ranking you relative to others in your city. In everything I'm going to show you here, we're ranking people in the nation, and that's going to be important for something I'll come back to later. So in Salt Lake City, you see this upward sloping relationship. One statistic that I'm going to spend some time talking about, which is a simple measure of absolute upward mobility, a little bit different from the bottom to top measure I was talking about before, is the mean percentile rank achieved by children who grow up at the 25th percentile of the income distribution. So in Salt Lake City, this number is 46.1. So the way to interpret that is if you grew up in a household that was at the 25th percentile, so below average income, on average, you yourself reach nearly the national median. So just on the face of it, that's a substantial amount of upward mobility, right? You're growing up in a pretty low income family, you're getting pretty close to the national median on average. So let's now compare Salt Lake City to Charlotte, North Carolina. So in Charlotte, the same exact methodology, same data yields this relationship shown in red, where you can see that there's a much steeper gradient in Charlotte than Salt Lake City. And what that translates to is at the 25th percentile, you on average get to the 36th percentile if you were growing up in Charlotte, rather than the 46th percentile. To give you a sense of the magnitudes, at age 30, which is roughly when we're measuring kids' incomes in their early 30s, the 46th percentile of the US income distribution is about $29,000, and the 36th percentile is about $21,000. So if for a moment you imagine that we can turn Charlotte into Salt Lake City in terms of outcomes for low-income children, you would substantially change both the lives of those kids and what the economy looks like, right? Now, one pattern that you notice in this graph, which turns out to be a generic feature of the data, is that there's much less difference at the top than there is at the bottom. So these mobility relationships, they tend to pivot relatively high in the income distribution. So basically what that's telling you is that it matters much less where you grow up if you're from a rich family than if you're from a low-income family. And you can tell various stories for why that might be intuitive. I'll come back to talking about the role of schools, for example. And if you're rich, you might think, you're always able to access a private school or kind of insulate yourself from local conditions. But that turns out to be a systematic pattern in the data. Now, coming back to the statistic that I started out with, the odds that you rise from the bottom fifth to the top fifth, in Salt Lake City, that number is nearly 11%. In Charlotte, it's 4.4%. So here you see that the odds of success are varying by a factor of 2.5 across these places within the United States, basically on the same order of magnitude or larger than the variation across countries. So we actually think one of the key themes that comes out of this work, I think, is that social mobility appears to be a very local phenomenon. It's not about large-scale cross-country differences, which there are. There are substantial differences even within relatively narrow geographic areas. And I would suspect the same is probably true in the UK, and one could study that if you had similar data here, which I think would be quite interesting. So let me now generalize from the two examples that I showed you and compute these statistics for all 740 what are called commuting zones. Think of them as basically metro areas. They're aggregations of counties, but they also cover rural areas. So it's a complete partition of the United States. And for each place on this map here, we're showing you that simple upward mobility statistic. Basically, you get very similar results if you use different measures of intergenerational mobility. So for simplicity, I'm showing you this intuitive statistic of going from the bottom 20% to the top 20%. And the way this map is constructed is it's a heat map. And the colors are coded so that lighter areas are areas with higher levels of upward mobility. So in the very lightest areas, your probability of going from the bottom 20% to the top 20% exceeds 16.8%. So remembering that 20% is the max, that's what it would be in a perfectly mobile society where your parents don't matter at all. This is actually an extremely high level of upward mobility, considerably higher, for instance, than you see in the Scandinavian countries. And then on the other end of the spectrum, in the darkest red colors, you see mobility rates of less than 4.8%. If you're born in a low-income family there, your odds of escaping poverty really do not look very good. So there's a lot of data here, and let me just describe some of the broad patterns that we see. So first of all, you can see clearly that there's very broad regional variation. The southeast of the US in particular has very low rates of mobility, and some of the Rust Belt cities, urban areas around the Great Lakes have very low levels of mobility. In contrast, much of the rural United States here in the Great Plains or California looks like it has much higher levels of mobility. Now, while your eye is initially drawn to the regional variation, there's actually considerable variation within regions or within states. In fact, 45% of the variance in this map is within states. So let me draw your eye to one example. Look at Pennsylvania here versus Ohio. We generally think of Pennsylvania and Ohio as being pretty similar states in their economic structure in terms of demographics. But Ohio looks substantially worse than Pennsylvania in terms of rates of social mobility. So it's interesting to think about why exactly you see such a sharp contrast. A third pattern that you see, which is a little bit hard to pick out in this map, is that urban areas, for instance, Chicago here in the upper right corner of Illinois, or Milwaukee in the lower right corner of Wisconsin, have much lower rates of upward mobility than rural areas. So in general, places like Iowa or the rural Midwest are the lightest colors on this map. So in understanding that phenomenon, it's very important to note that we classify kids based on where they grow up and not based on where they live as adults. So one of the great features of the tax data is that we can track you no matter where you're living as an adult. So 70% of these kids in Iowa who are moving from the bottom 20% to the top 20%, they're living in Chicago, San Francisco, New York as adults. So there's something about these rural areas that helps low-income kids do well and then ultimately move to jobs in other cities. But what's remarkable is that it seems like these rural areas repeatedly generate good outcomes for low-income kids, even though there's sort of a brain drain effect where the successful kids often tend to leave the community. And then a fourth pattern that you see, which just illustrates the granularity and I think the precision of the data, is if you look here at South Dakota and North Dakota, some of the states with the highest levels of mobility in the US, you see that there are much, much lower levels of mobility in one particular part of the state, which are the darkest red parts of the map, where you have less than a 3% chance of moving from the bottom to the top 20%. So what are those places? Those turn out to be some of the largest Native American reservations in the US, where historically we know, based on earlier work, that there's chronic intergenerational poverty. So you're picking that up in these statistics as well. So in the big map, it's hard to see the biggest cities. So let me just spend a moment running through the 50 biggest metro areas. At the top of the list in terms of upward mobility based on the bottom to top statistic, you have places like San Jose, San Francisco, Salt Lake City, Boston, and so forth. They're dispersed throughout the US. And in these places, the odds of moving from the bottom to the top are nearly 3 times as large as the cities on the other end of the spectrum, Charlotte, which I started out with, Milwaukee, Atlanta, Dayton, Indianapolis, where your odds of moving from the bottom to the top are on the order of 4 to 5%. So naturally, given that evidence, one is interested in understanding both from an academic and a policy point of view what drives that difference, the variation in social mobility across areas, and ultimately from a policy point of view, what might we be able to do in the places like Charlotte that have very low levels of social mobility to make them more like the lighter colored places on the map. So the first clues for us as researchers came from the fact that the spatial variation in inequality emerges at very early ages, and in particular, well before kids enter the labor market, which I think is useful in narrowing the net of potential explanations. So for instance, one explanation you might have had, which President Obama actually talks about a fair bit, is that you need to have jobs that provide ladders for opportunity, where maybe in some sectors you can climb up more easily, and in other sectors it's harder to do that. Well, what I'm going to show you is that actually it turns out that even before people enter the labor market, you see a lot of this variation emerging. So to illustrate that, let me start by showing you this plot here, which returns to the national level, but looks at a different outcome, college attendance rates. So what's being plotted here now is, again, parent income percentile on the x-axis, same x-axis as before. But on the y-axis, we have the percent of children attending college between the ages of 18 and 21. So each dot shows you the fraction of children attending college within each percentile bin of the income distribution. And you can see that there's this incredibly strong upward sloping relationship between income and college attendance rates in the US. If you're at the top of the income distribution, you have nearly a 95% chance of going to college. At the bottom of the income distribution, it's closer to 25 or even 20%. So nearly a 70% percentage point gap in college attendance rates. So now you can do this exercise again by commuting zone for all the 740 areas in the US and estimate the slope, which is 68% in the US as a whole, within each area. And this map here shows you the results of that. So the way this is constructed is we estimate the slope of that relationship, the college attendance versus parent income rank gradient, separately for each area. And again, we color the areas so that the lightest places have the flattest slopes, that is the least disparity in college attendance. And the darkest colors are places with the greatest disparity in college attendance rates. So broadly, what I want you to take away from this map is that it looks fairly similar to the intergenerational income mobility map that I started out with. It's not identical. The correlation is about 0.7, but it's substantially similar to what we started out with, suggesting that by the time kids are 18 or 19 years old, you're already starting to see quite a bit of this difference in kids' outcomes and the spatial variation across places. Now, to take another example of such an outcome, even moving a little bit earlier, here we look at teenage birth rates for female children. And we plot that against parent income percentile again. And what you can see is that there's a remarkably strong relationship, once again, between teenage birth rates and parent income percentiles. At the very top of the distribution, you essentially have no chance of having a teenage birth. Remarkably, at the bottom in the bottom 1%, the fraction, 30% of women have children while they're teenagers in the US. Right? So once again, we compute this slope of this gradient by area and put that on the map, with lighter colors being places with a smaller gap in teenage birth rates. And once again, it looks broadly similar to the map we started out with. So the point is, by the time kids are 15, 16, 17 years old, you're starting to see this disparity in outcomes across the income distribution in a way that varies across space. So that suggests to us that the factors that matter are things that affect you while you're growing up, and less so purely labor market conditions. It could also be anticipatory responses to the labor market situation, but clearly something's got to be changing while kids are growing up. Now, further evidence comes from people who move across areas. So this is a project we're currently working on with my colleague Nathan Hendren at Harvard, where we're trying to go a step further relative to the descriptive evidence that I've been showing you, and actually show you that it's the causal effect of places that's driving this variation. So consider two very different hypotheses that might explain the maps that I've been showing you. One is that the people who live in Salt Lake City are just different from the people who live in Charlotte. And that is, of course, true as a fact. For example, Salt Lake City has a lot more Mormons than Charlotte. But so one explanation is that it's just heterogeneity in the types of people who live in different places. A different explanation is that it's something about the environment in Salt Lake City, the policies, the community, something that's, maybe the schools, that's affecting children. And so ideally, the way you would discriminate between those two hypotheses is to have a randomized experiment where you take some children and randomly assign them to Salt Lake City versus Charlotte versus other places and see how their outcomes vary. Now, one of the advantages of having so much data is we can construct something that looks sort of like that experiment by looking at people who move across areas. And it tells us a story that places do seem to have causal effects, and again, that what matters is relatively early in children's experience. So let me describe this evidence. Basically, we study the outcomes of children whose parents move from one city to another, and we ask whether children who move at young ages to a city with higher rates of upward mobility do better themselves, okay? So to make this concrete, let's take a family that starts out in Dallas, Texas, which turns out to be relatively in the middle in terms of the upward mobility distribution. And one family moves to Salt Lake City, a place with very high rates of upward mobility. And another family moves to Atlanta or Charlotte, a place with very low rates of upward mobility. Let's look at what happens to their own children for these movers, okay? So that is illustrated in this chart here. So the way this is constructed is, the easiest way to think about it is the people on the right side of this chart, they're moving to places like Salt Lake City. And the places on the left, the people on the left side of this chart are moving to places like Charlotte. And what's being plotted on the y-axis is the actual rank of their children relative to the average person in Dallas, okay, when the child is 30 years old. So we track the children forward. We're taking a set of families who move when their kids are less than 13 years old, and we're asking, how does your child's outcome look when they're 30 years old, depending upon where you move? So the first thing that you see from this graph is that there's a very strong upward sloping relationship here, right? If you move to an area where based on the prior residence, we would predict your child would do better, your child does in fact do systematically better on average. The kids who are moving to the San Jose's and Salt Lake Cities are doing better on average than the kids who move to the other places. Now what's more is here I've grouped all the children, all the families who moved when children were less than 13 years old. Now you can imagine doing this analysis separately by the age of the child at the point that you moved. So this graph here plots the slope that I showed you on the previous slide, and we estimate that slope separately for each age at which the child, the age that the child is when the parent is moving, all right? So think about each of these dots as basically the impact of moving to a 1 standard deviation better place on your child's outcome. So what you see here is actually a remarkable relationship, which I think is of interest in its own right, in that it looks like it's a linear dose-dependent relationship. Every extra year you spend in the better place, your child does proportionately better. And it's not that there's any one age that seems particularly critical. Every extra year that you're in Salt Lake City rather than in Charlotte, your child is doing better as an adult. Now, here, over here on the right of this line, the idea is that this basically constitutes a placebo test. So the logic is, hopefully after your kids are 20 years old, they're not moving along with you when you move from one area to another, because presumably your children have left the house by the time they're 20. And so these people over here, they're moving from one neighborhood to another neighborhood after their children have left the house, and you can see that there's no longer a significant effect, and you no longer see that downward slope beyond that point. That's exactly what you'd expect to see if the place is having a causal effect and if it matters, right? So the fact that this is downward sloping once again suggests that it's something that's affecting you while you're growing up rather than conditions purely in adulthood. Let me just say one more thing for the academics here, which actually convinces me that this is a real effect and not one that's driven by sorting. You can do this analysis within families, comparing siblings who were different ages when they moved. So imagine I moved from Dallas to Salt Lake City with a 10-year-old and a 14-year-old. The 10-year-old gets 4 years of extra exposure to the better place. And if you look at the difference in outcomes of the siblings, you see that the 10-year-old does proportionately better than the 14-year-old, which I think is very hard to explain with the story beside the causal effect of place, okay? So now, all that evidence I think is interesting in suggesting that places matter, and maybe from an individual family's point of view, what you could take from it is that you want to try to live in a place that has higher levels of upward mobility. From a policy perspective, that's not a particularly useful result, I think, because we can't really whole-scale move everyone from Atlanta to Salt Lake City. And so what we really want to understand is what are the characteristics of these places that have lower rates of upward mobility. And so that's what I'm going to turn to next. So what we started out doing is exploring racial differences. So the reason for that is the most obvious pattern for the map, for those who are familiar with US demography, is that areas with larger African American populations have less upward mobility. So the southeast of the US, cities in the Rust Belt like Cleveland and Milwaukee, all have substantial African American shares. So a critical caveat in interpreting this correlation, which is shown here on this diagram, very strong relationship between the fraction of black residents in an area and rates of upward mobility, is the following point, which is that white Americans also have lower rates of upward mobility if they live in areas with more African Americans. So if you imagine redrawing that map strictly using only white Americans, you find that the white people who are living in Atlanta, in Charlotte, et cetera, also have much lower chances of moving up in the income distribution than people in San Jose or San Francisco. So this cannot be purely the effect of race at the individual level. It's not just saying that African Americans have a lower chance of moving up in the distribution themselves. It's something about race mattering at the community level. Racial shares appear to be correlated with outcomes for people of all races. So why might that be? There are many theories in sociology for why you might see a correlation between racial shares and economic outcomes. I'm going to focus on one of them here, which is segregation. So the logic here is very simple. There's a historical legacy of greater segregation in the US in places that have larger African American shares. So cities like Atlanta or Charlotte are much more segregated than some of the cities on the West Coast. That segregation, importantly, racial segregation, tends to go hand in hand with income segregation. So in places where blacks are separated from whites, you also have low-income whites separated from high-income whites. Now, such segregation, there are many theories which suggest that that could have detrimental effects on children's outcomes. This might be because of peer effects. You're less exposed to kids who are doing well. Could be because of networks. You don't have access to the same types of jobs and so forth. Could be because of the provision of public goods. If you're in a really integrated area, you get to benefit from the property tax base that funds the schools that you attend. If you're in a very segregated area, your school doesn't have a lot of resources the way schools are financed in the US. So many potential reasons you'd see a relationship. Now, so what we turn to is first investigate in detail the relationship between segregation and rates of upward mobility. So in order to do this, initially you think you need to formulate an index of segregation. And there are many ways sociologists measure the degree of segregation in an area, and that's what we ultimately do. Turns out the patterns are so stark here that I'm just going to show them to you visually using a couple of examples. So this map here illustrates the degree of racial segregation in Atlanta. So the way this map is constructed is done by a demographer named Dustin Cable, that he takes 2010 census data and represents each person living in Atlanta by a single dot on this map. And the dots are colored so that whites are blue, blacks are green, Asians are red, and Hispanics are orange. You can see that Atlanta is an unbelievably segregated city, right? The blue dots are completely separated from the green dots. And correspondingly, we find that Atlanta has one of the lowest rates of social mobility in the United States. If, in contrast, you look at Sacramento, which has the same black and Hispanic share, the same minority share as Atlanta, the dots are far more interspersed, right? You see that there's much more integration in Sacramento than in Atlanta. And in fact, you see that Sacramento is one of the highest upward mobility cities in the US. So more generally, going beyond the two particular examples I'm showing you here, if you correlate using a tile index of racial segregation or a dissimilarity index, you find a very powerful relationship between the degree of segregation in an area and rates of upward mobility. Now, I'm going to now talk about various other factors that we find to be quite strongly correlated with upward mobility. I won't spend quite as much time on each one of them, so let me list them here. So as I said, the first factor we identify as being a strong correlate of mobility segregation as proxied for by racial and income segregation. Another measure you might use, which actually Paul Krugman wrote about in the New York Times when we put out these data, is commute time, so a measure of the density of a city. Turns out that even stronger than an even stronger correlate than these segregation measures is a measure of how sprawling the city is. For instance, what average commute times look like. And places with shorter commutes to work tend to have much higher rates of upward mobility. Now, once again, that could be because of various reasons. It's easier to access jobs, you're less cut off from other people. There's something else that's a factor. Commute times are picking up some other feature of dense cities that help kids move up in the income distribution. Not totally clear how to interpret that, but that turns out to be a strong correlation, which is related to this general theme that being near more affluent people seems to help kids. Now, a second factor that we find is quite strongly correlated with mobility, which has received a lot of attention in the cross-country literature, in the so-called Great Gatsby curve that Alan Kruger has coined, is the degree of income inequality in an area among parents within a generation. So we find that places with a smaller middle class have much less mobility, or places with larger Gini coefficients have much less mobility. Interestingly, however, if you'd use a different measure of inequality, one that has received a lot of attention in the recent literature because it has increased so much in recent years, that is upper tail inequality. So think about, for example, top 1% income shares. Turns out top 1% income shares are not very strongly correlated with differences in mobility across areas. And you could see that from the map that I showed you. So for example, San Francisco and San Jose have incredibly rich people, but they also have some of the highest rates of upward mobility in the US. What those cities do have, however, is a much larger middle class, in the sense that the fraction of people who are between the 25th and 75th percentile of the US income distribution is much larger in a place like San Jose or San Francisco than Atlanta, for example. Okay, so again, you can't quite interpret any of this causally, but that pattern might suggest that it's something about opportunities to move into the middle class that really strongly predicts differences in mobility across areas. A third factor, which I'm going to come back to in more detail in the second part of this talk, is the quality of schools. So as is quite intuitive, you might expect that schools play an important role in social mobility. It's fairly difficult to measure the quality of schools well across areas with available data in the US. So we use a few rough proxies that have been suggested in the prior literature, like the amount of expenditure on schools, the size of classes, and outcome-based measures like test scores, controlling for parent income. And across all of these measures, even though we don't think they're particularly great measures of school quality, we find quite strong positive correlations between the quality of schools in a metro area and rates of upward mobility. Now, the last two factors that we look at are factors suggested by sociologists. So the next one I'm going to discuss is family structure. So it turns out that actually the single strongest correlate in the data of upward mobility of all the dozens of things we looked at is the fraction of single parents living in an area. So areas with more single parents have substantially lower rates of upward mobility, and that univariate correlation is something like 0.75. So what that means is if I showed you a map of the fraction of single parents in the United States, it would look quite similar to the maps that I've been showing you. Now again, a very important caveat in interpreting this, and I think this has actually been, this result has been misinterpreted in the media and the public debate in the US, is this strong correlation exists even if we condition on the child's own parents' marital status. So that is, if I take this set of children whose own parents are married, if you live in an area with more single parents, even if your own parents are married, you have lower rates of upward mobility. So this harkens back to the finding on race, right? It's not just an individual level effect. It's something about communities that have a lot of single parents. There's something that's different about them. And figuring out exactly what that is, I think, is an extremely important question for future research. And then the fifth strong correlate that we find is measures of social capital. So some of you may know my colleague Bob Putnam's famous book, Bowling Alone, which was about the idea that social capital is deteriorating in the United States and other countries, where by social capital he means things like social cohesiveness, the fraction, say, of religious participation in an area. You can see how Salt Lake City, with the large Mormon church presence, kind of fits that example. We find very strong correlations with such measures of social capital and rates of upward mobility. Now, the reason Putnam's book is called Bowling Alone is one of the proxies he uses for social capital is the number of bowling alleys in an area. And I was actually amazed to find in our own data that the number of bowling alleys is very strongly correlated with rates of upward mobility. But I think that also serves as a good caution in interpreting all of these correlations, because I'm sure the policy solution here is not to build more bowling alleys, right? So that's why you want to make sure you interpret all of these as correlations and not causal effects, right? Okay, so And that's exactly what I want to turn to in the remainder of this talk. So I think the 5 factors, the way you should interpret them, is that they give you hints about where to look to improve social mobility, but they do not identify causal mechanisms or policy tools. We need to do more work to figure that out. So what specific policies can improve upward mobility? I'm going to focus here on one set of feasible policies, improving the quality of education. Now I want to be very clear. I'm not suggesting that all of the other factors don't matter. I'm focusing on education because it's something we're able to study well, given the data that we have, and because I think it falls into the policy domain in a way that other factors don't easily do so. So for example, if segregation does matter, even if it does matter, or family structure matters, it's much harder to figure out how to change the degree of segregation in an area or change family structure. It's much easier to figure out how you might improve the quality of schools. So I think there's good reason, even though I think many other things contribute to this problem, I think there's good reason to think about schools as a potential area where you want to focus on policy interventions. Now, when I discuss this work on education from a separate set of papers I'm going to turn to next, a lot of what I'm going to do is rely on test scores as a way of measuring teacher quality, and test scores as a potential proxy for long-term impacts. So often when I talk about this work, people start, I'm going to show you things like your kindergarten teacher matters a lot for your outcomes when you're 30 years old as judged by test score impacts. So people often say, what are you possibly testing kindergartners on that has any predictive impact many, many years later? So let's do an example. This is the Stanford Achievement Kindergarten Test, a question from that. And the way it works is like this. Let's say I'm the teacher. I'll say a word to you. Listen for the ending sound. You circle the picture that starts with the same sound. So read those directions carefully, because when I've given this talk in the past, people have come up to me at the end and said, I really liked your talk, but unfortunately I felt bad because I got the kindergarten test question wrong. So the word here is cup, and hopefully you know the answer is pencil and not duck. And so what we did as researchers is asked, how is the child who unfortunately said duck instead of pencil doing 25 years later when we see his earnings in the tax data? And here's your average earnings when you're between the ages of 25 and 27, plotted against your kindergarten test score percentile. So top of the class versus bottom of the class. So let me explain how this chart is constructed so that you understand exactly what's going on. So this is data from the Tennessee STAR experiment, a very famous experiment in education, which involved about 12,000 children in the state of Tennessee. It's a relatively disadvantaged population, so they have low earnings on average. But the key thing I want you to notice is that the average level of earnings for people at the top of the class is nearly 2.5 times as high as kids who scored at the bottom of the class on the kindergarten test. Now, to be clear, the way this graph is constructed is it's again a binned scatter plot, not a raw scatter plot. So what we do is we divide the x-axis into 20 equal-sized bins, 5 percentile point bins or vintiles, and we're plotting mean earnings within each of those bins, okay? So the important thing to take away from this graph is the magnitude of the impact. But this graph, even though the points are closely aligned with the best fit line, the red line, should not be interpreted as saying kindergarten determines everything in your life, right? In fact, the R squared is only 0.05. There's lots of other stuff that affects your outcomes. The point is, some significant part of it can be predicted by kindergarten test scores, and the magnitude of the impact, if you imagine, suppose we could move kids to the right side of this chart, perhaps through better education, better teachers, something like that, that's where I'm headed, then maybe we could substantially improve children's earnings on average, even though many other factors also affect earnings, right? So that correlation suggests, I think, this is the way people in the educational literature interpret it, that improving children's performance in school, as measured by standardized tests, for instance, could potentially have lasting benefits. But it does not tell you exactly how you want to do that. So simply spending more money on schools, I think it's unclear whether that has a significant effect on kids' outcomes. So Rick Hanushek, this point is somewhat debated, but Rick Hanushek and others have a number of papers basically documenting that differences in expenditure across areas, and there are quite substantial differences in the US in terms of school expenditures and across countries, they don't really correlate that well with student performance. So I don't think the first solution you think of, let's just throw more dollars at the problem, is necessarily the right way to think about it. I think we really need to dig into what the education production function looks like and understand at a deep level which aspects of education are most important. Is it the quality of teachers? Is it the size of classrooms? Is it resources, for instance, giving every child in a school a laptop, which is something many schools are talking about? So what we've done in our research is studied one particular aspect of this that looks quite important, which is the impacts of the quality of teachers you have in childhood. And the way we do this is using another example of big data applied to public policy. Here, we're using information from the largest urban school district in the US, where we get data on 2.5 million kids who have written 18 million tests over the 20-year span that we study. And we take those 2.5 million kids and link them to the federal income tax returns that I was talking about previously to look at how, say, your third grade teacher affects how much you're earning, which college you go to, and your probability of having a teenage birth, all right? Now, in order to talk about the impacts of teacher quality, I first need to define what I mean by the quality of a teacher, right? And there are many ways you might think about doing that. One prominent measure, which is very important in the current policy debate in the US and many other countries, is so-called teacher value-added measures. Now, there are a number of statistical issues surrounding these value-added measures, but conceptually, they're quite simple. Basically, a value-added measure is seeking to answer the following question: how much does a teacher raise his or her students' test scores on average? So let's say I'm a fourth grade teacher. The way I'd calculate my value added, roughly speaking, is take my students' end of fourth grade test scores, subtract their end of third grade test scores, and take the mean, and I call that the value added of the teacher. That is the average level of progress that the students made on these standardized tests that are given every year. And we compute that separately for every teacher. Now, what I want to show you and what I want to assess is whether being assigned to a high versus low value added teacher has an impact on kids' outcomes and how large that impact is and how that might translate into the questions about social mobility that we started out with. Now, in order to answer that question, again, it's useful to think about what the ideal experiment would be. So if we have, as we do, data on students' test score performance, and we compute these value-added measures for a set of teachers in a school, what we'd want to do is take a new batch of students who show up, say, for kindergarten in a new school year, and we tell the parents, look, there's this very important policy question we want to answer, which is how does teacher quality affect your students, your children's outcomes? So we're going to run a randomized experiment where some of your children will be assigned to these teachers who we've identified based on prior data as being ineffective, and others of you your children will get highly effective teachers. So you can imagine that most parents don't want to be involved in that type of experiment. So once again, what we're going to do is take advantage of the size of the data we have and use a quasi-experimental approach that mirrors that experimental logic. So we're going to exploit the fact that there's a lot of teacher turnover in most schools. Lots of teachers coming in, going out, going on maternity leave, things like that. And so as a result, very similar students who just happen to be different in terms of when they reach a given grade are often exposed to very different teachers. And we're going to exploit that to generate what looks essentially like a randomized experiment from the student's perspective. So this graph illustrates that result. So I want you to think about tracking a given school over time, and we're looking at a particular cohort, different cohorts of children who reach fourth grade in different years. So let's think about performance in fourth grade. And what happens in the school is that in the 1996 school year, a very high value added teacher, a teacher whom we've identified based on prior data as being in the top 5% of the value added distribution, such a teacher arrives in this school and starts to teach subsequent cohorts of students. So what I want to do is look at how test scores evolve in this school in fourth grade around the entry of this superstar teacher. So this is now using real data from thousands of such events. This is an event study thousands of such events in our data set. We're plotting test scores, and you can see before that teacher comes in, test scores are kind of bouncing around the median with no particular trend. As soon as that top 5% teacher arrives, test scores immediately jump, and they continue to stay high for subsequent cohorts of children. Now, you all know, paralleling the randomized experiments we've been talking about and thinking back to a science class, in any such experiment, you have a treatment group, which is what I've shown you here, but you also want to have a control group to make sure that nothing else changed at the same time when this better teacher came in. So in this context, there's a very natural control group, which is to look at third graders. The idea is that the better teacher came in fourth grade and improved fourth grade children's outcomes, but there was no change in third grade at the same time. So we shouldn't see any change in third grade around the point of entry of this teacher. So let's look at third grade test scores. And in fact, they're totally flat around the point of entry of this teacher. So building upon evidence like this, and I should note this also works equally in the opposite direction, where you have this teacher here who doesn't want to be there, and he's in the bottom 5% of the value-added distribution. And he, unfortunately, pulls test scores down immediately as soon as he comes in relative to the prior grade. So throughout the distribution, we find very consistent impacts of teacher entry and exit in a way that looks really like teachers have causal effects on students' test score outcomes. Now, that result by itself suggests that teachers matter for standardized test performance, but it doesn't tell you whether teachers matter for the ultimate long-term outcomes that we care about, for instance, in the context of social mobility. So the more important result, I think, actually, is the following, which is this plot here, using similar variation, plots the probability of attending college now using information from the tax records when you're 20 years old versus the quality of the teacher you had when you were, say, in third grade. So here you happen to get a very high value-added teacher. The other end of the spectrum, you got unlucky and got a very low value-added teacher. And you see that there's a very strong relationship between the quality of the teachers you had and your probability of going to college. Let me say a quick word on magnitudes. If you're at the bottom end of the spectrum, you have about a 36.5% chance of going to college, and there's about a 2 percentage point gain if you got a very high value-added teacher. Now, on the face of it, that might not seem like a big effect, but what you have to remember is that this is the impact of a single teacher in a single grade. So imagine that if the impacts of teachers are additive over time, and you had a better teacher not just in third grade, but also in fourth grade, fifth grade, sixth grade, if these effects accumulate, you could potentially end up changing college attendance rates by 5, 10 percentage points, which would again dramatically reshape what kids' lives and what the economy looks like. Now, you also find a strong correlation between the quality of teachers you had and earnings, and I'll come back and talk about the magnitude of this effect in a minute. And then beyond standard economic outcomes, this is teenage birth rates versus the quality of teachers you had in elementary school. Women are significantly less likely to have a teenage birth if they happen to have a high value-added teacher when they were in elementary school. So how large are these effects? Here's one feasible policy exercise that people have been talking about in the US that I think illustrates the magnitude of the impacts of teachers well. So let's take the bell curve of teacher quality and imagine the following exercise. We're going to take the teachers who are rated in the bottom 5% of the distribution, and suppose we replace those teachers with teachers of average quality, which is something we could feasibly do by hiring new teachers in principle. What impact does that have? Based on the estimates that I showed you, that change would increase the lifetime earnings of a child by $50,000, which translates to $1.4 million per classroom of average size, 28 students in our data. And if you view this as an investment and discount it back to present value at a 5% interest rate, that's worth about $250,000. So quite a substantial return to potentially improving teacher quality. And coming back to what we started out with on social mobility, the magnitude of these effects suggests that if you could improve the quality of teachers and more generally the quality of education, you could potentially profoundly affect rates of upward mobility. So let me wrap up, given the policy interests of people here and the fact that we have policymakers here, by talking about some of the policy impacts in the United States and some of the policy lessons going forward. So in the US, the types of results I've been showing you have been picked up in the public debate. Here you see Nick Kristof writing in the New York Times that exactly the result that I just showed you. Suppose that the bottom 5% of teachers could be replaced by teachers of average quality. That's more than $1.4 million in gains for the classroom. And then both at the federal and local level, here you see the President of the State of the Union saying we know a good teacher can increase the lifetime income of a classroom by over $250,000. And the White House has tried to initiate a number of programs to incentivize local school districts to do more performance evaluation and try to retain and attract the best teachers. And similarly here, Mayor Bloomberg in New York, they're trying to do more things along these lines. I think the most important policy impact is actually outside the political domain and in the context of litigation, where there's a very important case in California, Vergara versus California, which I think could have a profound effect on education in the US, where it's based on the type of results I've been showing you, teacher quality is a key determinant of educational effectiveness and has a profound impact on students' lifetime achievement. What they're trying to do here is a group of parents suing the Los Angeles School District, where currently 99% of teachers get tenure, and there's absolutely no evaluation in terms of which teachers are better or worse, and there's no systematic effort to try to keep better teachers, which I think is really the problem. So high value-added teachers, they're also good at doing many other things where they could potentially get paid a lot more. But the way pay works in California and most other places in the US is it's purely based on experience. And so what they're basically trying to move toward is argue that this disproportionately affects minority children because there are more low value-added teachers in high minority schools, and this exacerbates these social inequities, which is illegal, violates California constitutional law. And so they're trying to use this type of evidence to potentially improve the schools there. So let me conclude by just highlighting a few policy lessons. So one thing that I've stressed in the latter part of this talk is that improving the quality of primary education is something that one can do. There are ideas people have on how to do this. It need not just be about teachers, could be about many other inputs as well. I think increasingly we have the evidence to really understand which things matter and how we can measure things better. I want to stress that it's not necessarily just about spending more money. The US already spends more money than other developed countries with better outcomes. It's about spending that money more efficiently, I think. And so to take one example, which people often quote in the education literature, a place like Finland, where you have very good educational outcomes, what you hear about Finland is that teaching is a profession that many of the smartest children aspire to go into, whereas that's really not the case in the United States, or I think in many other countries, where you don't necessarily attract the top talent to teaching. And I think given the potential impacts we see here, that would be a very sensible thing to try to fix. Second, coming back to the social mobility work and stepping back from the particular education lever, I think it makes sense to take a place-based approach to improving opportunity. So the discussion to this point is typically focused on national policy changes. What can we do at the US level in terms of changing colleges or the tax system, things like that, to improve social mobility? And while I think there's an important role for national policy changes, as I've tried to illustrate, this also appears to be largely a local problem. And so focusing on improving specific cities or even within cities, neighborhoods, we studied the data at a fairly aggregated level just for simplicity. My guess is there's a lot of heterogeneity if you were to zoom in within each of these places. So focusing in a much more targeted way using place-based policies could be a very sensible thing to do given the type of variation that we see. Third, more broadly, I think harnessing the type of big data that I've been exploiting here can be very useful to develop a scientific evidence base for evaluating policies. So what we've done in this particular context is we've released mobility statistics by county on the project website, equalityofopportunity.org, so that people can look up their own areas and other researchers can study, in this county, social mobility appears to be very high, and I know about this program that was put in place. You have these statistics by birth cohort, and you can try to figure out what really seems to matter. More generally, we're working with the government to create automatic annual reporting of mobility statistics by county so that people who are interested in these issues can measure the impacts of new interventions. And finally, one thing I've been heartened by in working on these issues is that just collecting and disseminating local performance data seems like it can spark social change. So to give you one example, the mayor of Atlanta wrote a response to our paper after it came out and talked about why A, social mobility, the lack of social mobility in Atlanta was not his fault, and B, what he was trying to do to fix the problem. So let me conclude with this slide here, where come back to some of the statistics that I've shown you for the US and where the UK falls in that distribution. In many places, I would say even the UK as a whole, you have relatively low rates of social mobility. Now, I think you can look at that in two ways. You can either look at that from a pessimistic point of view and say, isn't it too bad that kids from low-income backgrounds really don't have that much of an opportunity to succeed on average? But I actually see it rather as an opportunity and a challenge. So the opportunity is that we see between areas that are relatively similar that there are vast differences in rates of upward mobility. And so that gives me hope that if we can figure out how to make a place like Memphis or Chicago look more like San Jose or Dubuque, Iowa, you could potentially really change what social mobility looks like in these places. The challenge, I think, for the researchers who are here is to figure out what exactly is driving these differences in social mobility across places and understand exactly what the causal mechanisms are. And the challenge for the policymakers who are here is to take some of the solutions that researchers come up with and enact potential policy changes to improve social mobility. I'm hopeful that working together, we'll be able to have an impact on these very important issues. Thank you.